In this video, I will be going over lesson 23, which is about interpreting sample results. Our first question here says that each dot on the dot plot shows the number of people in a 10-person random sample who said they will vote for a certain candidate in a local election. How many samples does this dot plot represent? Okay, well, to figure this one out, all we need to do here is actually just count how many dots we see on our dot plot. Oops. Okay, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer here is going to be 10. There are 10 samples. Our next question has that same dot plot, and we want to know, it says, vote for a candidate. Select all that applies. So we want to use these descriptions and match it to the dot plot. This first one here says it is likely that 40% of people in the local election will vote for the candidate. Okay, well, oh, hold on, wait 1 second. I see what I did here. Okay, let's reread this top part because it might make a bit more sense. Each dot on the dot plot shows the number of people in a 10-person random sample who said they will vote for a certain candidate in the local election. So each one of these dots here represents 10 people. Okay, so this one says that it is likely 40% of people will vote in the local election. But if I look here where the 4 is, there's only one dot. So this is going to be a no. The next one says that the candidate will likely win the election. So I'm going to say yes. If I look all the way over here, there's a lot of 8s and 9s. Those are pretty high numbers. So for me, that tells me that that candidate is more than likely going to win this election. The next one says that it's likely 50% of people in the local election will vote. Again, this is no, because 50% would be kind of around this area, but most of our dots are way over here. Candidates look likely to tie, lose. Those are both no, because we're saying that he's likely to win. And then this last one, where it says it's 80% of people are going to vote for him or her in the local election. That is true, because if I look over here, majority of my dots are around my 80% or my 8. All right, our next question here says that the average height in inches for basketball players for 5 teams of 10 players are shown in the table. Which team has an average height that is much different from the others? Okay, well, for this one, all we have to really do is just let's look at our numbers that we have here. Most of these are in the 70s range, right? I have 75, I have 78, 74, 76. However, 65 is significantly shorter than the rest of the averages of teams. So the Wombats are going to have the most different average height. Our next question here says that the average height in inches of 5 teams of 10 players are shown in the table. The question says, which of the following reasons could explain why one team has a much different average height than the other? Select all that apply. The first option says an error was made when finding the average height of players on the team. That could very well be a reason why that one team has such a different average. Say you forget to add in one person's average, right? You forget to add one of the players' heights. That can drastically change your answer. The next one says one member of the team is much taller than the other players on the team. One member being much taller won't cause that big of a difference. The second one says all members of the team are taller than other players. Well, the one that's much different, they're obviously shorter because it's a smaller number, so they're not going to be all taller. However, they could be all shorter than other players. That is one thing that could very well be happening here. Our next question says that a group of 7 surveyors each polled a random sample of 100 people to find out if they like Brussels sprouts. The results are shown in the following table. Based on the results of the survey, what percent of the population can we reasonably expect to like Brussels sprouts? Okay, so this table's a bit weird. Let me kind of break this table down a little bit. It tells me up here that each of these random samples has 100 people. Okay, so in group 1, there are 100 people that were asked. Same thing in group 2. So 29 out of those 100 people in group 1 said they like Brussels sprouts. In group 2, 32 out of 100 people. All of these are going to be out of 100 people. Okay? So they're all going to be out of 100 people. And if I kind of look at the numbers, they're all kind of giving me around that 30, right? Some are above, some are below, some are exactly at 30, but they're all around this number 30. So that means that I'd say there's around 30% of people are going to tell you that they like Brussels sprouts. All right, our next question. We have this same table, and here we want to know, based on the data, how many people in a sample of 50 would reasonably be expected to like Brussels sprouts? Well, if we think about our last question, right, out of 100 people, 30% of them liked Brussels sprouts. So if we're cutting our sample in half, right, from going 100 to 50, we're cutting it in half. We're dividing it by 2. We're going to do the same thing to our percentage. So if I divide 30 by 2, I'm going to get 15%. So around 15% is likely to say that they like Brussels sprouts. All right, and that is it for lesson 23. Please let me know if you have any questions.